Welcome back to probability. Today we are on section 6.7 and 6.8, which are probabilities involving permutations and combinations. Now we talked about permutations and combinations early on in section 6.1, 6.2, 6.3. And then we also talked about probability in section 6.4, 6.5, 6.6. So if you don't remember those, you can always go back and watch those videos. This is taking those two and putting them together in one. So as a reminder, the formula for a permutation is the factorial of n. So if it's like 5, it's the factorial of 5, which would be 5 times 4 times 3 times 2 times 1 over 5 minus whatever your second number is, let's say 2. So 5 minus 2 would be 3, and then the factorial of that. And then you have combinations, which are very similar, other than the fact that you would put that first factorial in the front as well. Okay. So, and remember there are buttons that you can find on your calculator if you turn your phone calculator sideways or if you use one of the calculators at school. So here we go. On an exam, you are asked to list the 6 steps to solve a particular kind of problem in order. Think order of operations here. You guess the order of the steps at random. What is the probability that you choose the correct order? So I need to do a couple of things here. First of all, I know that my answer is going to be a fraction. Okay? On the top, I know that there's only one way to get that step correct. There's not multiple ways to get my answers correct. I need to list one certain way. So the probability would be 1 out of something. Okay, then let's talk about the probability of the different options that you have. Okay, so if there's 6 steps, and order in this case matters, we have to think, is order matters? Is that a permutation or a combination? Well, if I remember back, it is going to be a permutation. So I know that it's going to be a permutation. And my numbers, well, 6 is the only number that they give me. So I know I'm going to start with a 6, and since there's only 6 steps, that has to be my second number as well. Which means I now need to solve, because I can't just leave that on the denominator. So for my permutations, remember I take my 6 factorial over 6 minus 6 factorial, which is just going to cancel out. And so I just have 1 over 6 factorial, which in this case I know is 720. So 1 over 720, or 1 in 720. So if you think about that, it says you're asked to list 6 different steps, and order matters in this case. So there are 720 different orders that you could put this in, but only one of them is correct if you randomly choose them. That means you could do like 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 6, 5, or 1, 2, 3, 4, 6, 5, 4, 1, 2, 3, 4, 6, 4, 5. Lots of different orders that you could assume, but this is only one correct. Okay, so a school student council has 16 members, including 4 seniors. There are 4 members randomly chosen to represent the student council at school open house. What is the probability that all 4 council members chosen are the seniors? So when I think about this, remember it has to be a fraction. How many options of all 4 seniors are there? Well, there's 4 seniors. So I have to think along those lines. Order in this case actually does not matter, so it's going to be a combination. Okay, I'm going to have 16 combination 4 because I have 16 people and 4 get chosen. So if I think about that, you have the 4 people that get chosen, and then you have the different combinations. If I only have 4 people that I'd like to get chosen, and that says what's the probability that all 4 of them are the seniors, then that's going to make it a lot harder chance there. So I need to figure out my combinations. Now if you remember with combinations, we have our 4 on the top, and I start with 16, and I only care about the first 4. So 16 times 15 times 14 times 13, or I then have to divide by 4 factorial, which is 24. So if I work all of this out together, it's going to give me the denominator of 1820. Okay, so again, this is a really good time where that combination button would come in handy. So 4 out of 1820, well, that actually can be reduced as a fraction. All right, so I'm going to divide 1820 by 4, and it's going to give me 455. So 1 over 455. There's 1 in 455 chance that all 4 seniors are chosen. The number is actually a lot, well, in this case, the chances are higher than like the last problem we did because the order doesn't matter. And so it doesn't matter which senior I pick first as long as I get all 4 of the seniors in there. Okay, you guys all have a phone, and on that phone you have a passcode. And the passcode, well, you can. Many of you have the Face ID, but the passcode can be a 5-digit number. What is the probability of guessing someone's 5-digit passcode if the numbers can be repeated? Okay, so if you remember passcodes, you have to take, since there's 10 numbers, we would have to take 10 times 10 times 10 times 10, and since there's 5 of them, we're going to do that 5 times. Okay, well, how many numbers are going to be correct? Just 1. There's only going to be 1 number that is correct. So as I work that out, that's only going to give me 1, and that's going to be 100,000 chances. So if you don't know somebody's passcode, you have 1 in 100,000 times to try to get it correct if it's 5 digits long. And so that's why they lock you out after so many digits. All right, last couple. A bag contains 8 chips, numbered 1 through 8. 2 chips are drawn at random from the bag and laid down in the order that they were drawn. What is the probability that the 2-digit number formed is divisible by 3? Okay, so this one, it gets a little tricky because realistically, you need to go through and list all these and then figure out how many are going to be divided by 3. I believe that's the easiest way to do it. So you can list out 1 and 2. 1 and 3, 1 and 4, 1 and 5, 1 and 6, 1 and 7, 1 and 8, 2 and 3, 2 and 4, 2 and 5, actually 2 and 1, 2 and 3, 2 and 4, 2 and 5. Then what you do, and I'm just going to show you this here. So I went ahead and listed all of those. Then what you do, and you go through, and the 2-digit number formed is now divisible by 3. Notice that I did go ahead and repeat. So this is 1 and 2, but this is also 2 and 1. Okay? So whichever number you draw first gets laid first. Then I went through and I circled any number that is divisible by 3. And just a reminder, for numbers divisible by 3, if you add them together, so like 1 plus 2, if you can divide that by 3, then that number is divisible by 3. So 12 is divisible by 3. 2 plus 1 is 21. You can divide 2 plus 1, which is 3, divided by 3, and so 21 is also divisible by 3. So it's an easy way to think of it. So I went through and I found all of those. So now we have to go through and count how many options we have total and then how many are divisible by 3. So I know that there are 7 options in each column, and there are a total of 8 different columns, which gives me 56 options total. Okay? And if I look back and I count the numbers that are circled, I now have 20 that are circled, which again is a fraction that I can reduce. So that's going to go 10 out of 28. I can go even farther, and let's do 5 out of 14, and that's going to be my final answer. There's going to be 5 out of 14 chance that the probability of a 2-digit number formed is divisible by 3. So any 2 numbers that I pull out of there makes a 2-digit number. I'm going to have a 5 and 14 chance that it's divisible by 3. Fun little project. Maybe you should try it out and figure out what the experimental probability would be there. All right, your task now is to go do the activity that is posted on Google Classroom, and then you have a learning check, the 6.7, 6.8 learning check to finish up. Have a great day.